We calculated our gravitational potential energy by taking mass times gravity times height. We converted the feet, 10 feet, to meters, and then we got 3.05 meters for 10 feet. 12 feet gave us 3.66 meters. 15 feet, we got 4.57 meters. We did the mass times gravity times height. And the mass of the egg, we got to be 0.061 kilograms. So we did our calculations, and the gravitational potential energy for the 10 feet drop is 1.86 joules. The gravitational potential energy for the 12-foot drop is 2.23 joules, and the gravitational potential energy for 15 feet was 2.79 joules. Then from there, we set our kinetic energy equal to the joules we got for our potential energy to figure out our velocity through the equation 1/2 mass times velocity squared. And when the drop from 10 feet, we got 7.8 meters per second. The drop from 12 feet, we got 8.5 meters per second. And the drop from 15 feet, we got 9.6 meters per second.
In this video, Zach is going to drop the egg from 10 feet high. In this video, Zach is going to drop the egg from 12 feet high. In this video, Zach is going to drop the egg from 15 feet high. The law of conservation of energy states that energy cannot be created or destroyed. It can only be transferred from one form to another. So when Zach dropped the egg from the top of the ladder, it stored potential energy. And as he dropped it, the potential energy is converting to kinetic energy. And as it falls into the net, it converts from kinetic energy back into elastic potential energy.
Alright, so Mr. Essay, what we did with our boxes, it was a 9 by 10 by 12 foot box. And so what I did is I took part of my ghillie suit. I ripped my ghillie suit in half for this project, so I better get 100. So I ripped it, took the pants leg off, since it's a mesh material, a little bit stretchy too, so it's kind of a softer cushioning of the egg. And what I did is, that was our first layer. Then our second layer was a balaclava made for during the winter, and it's just really soft material, very elastic, so it makes it an even softer landing for the egg with the elastic energy. And so then from there, we do is, for the bottom too, we had a little bit of paper shavings. Get that in the video. There you go, paper shavings in there, and make it nice cushioning. It's almost like what firefighters use for people who are inside houses and buildings. They can't get them out fast enough, what they do is have them jump out the building and land on a net, or even a stunt double. It's the same theory. And so what we have here is, first, when the egg hits, see when the egg hits, it comes down, and with the net, how he taught us was the displacement of the energy makes it a softer landing or cushioning landing, so the egg wouldn't crack like in cars while they have steel bumpers versus plastic. And so when the egg hits the fabric, it comes in, disperses all the energy within all the fabric, and then lands on the second fabric, which is even softer, and it goes along that, and then goes down all the way down to the paper mache, which makes it even softer landing, and the egg did not crack. Alright, so Mr. Essay, we didn't have a lot of eggs, since we had a lot of casualties. So what we had to do with our last egg, to make sure that you would trust us and believe us, we draw a really weird face. Chase to
Say it was. There we go.
Alright, so Mr. Essay, we didn't have a lot of eggs, since we had a lot of casualties. So what we had to do with our last egg, to make sure that you would trust us and believe us, We draw a really weird face. Chase showed it in the video, and now is the cracking to make sure it's a real egg. Right?
Hit on the side.
That's some real eggs there.